All right. So we're finishing out the notes on 2.3. So we're looking at number 6. So what we're trying to do now is, if we're given a function, we are trying to come up with the equation for the parabola that we have. So first of all, we're going to identify the vertex. So looking at the vertex, write down what the vertex would be. Chloe, what's the vertex? We are on page 38, number 6. Right. So the things we need to know to be able to write the equation of the parabola, the formula we're always using is y equals 1 over 4p x squared. This 1 could be either positive or negative. The other formula we'll use is x equals 1 over 4p y squared. Those are the only two formulas we're going to need to use on here. So back to this problem, we have the vertex. Now we need to look and see what our p-value is, because the p-value is needed for the formula. So let's see, what is our p-value? Right. So now I have to say, since this parabola is opening up, then I'm going to have to use this formula here, and I'm going to have to use the positive because it's opening up. So now it's just a matter of plugging everything in. So I'm going to have y equals 1 over 4 times 5 x squared. So y equals 1 over 20 x squared. Questions on that? Not too difficult, is it? All right, so now we're going to look at the next equation. So when it opens up or down, we're using this formula. When it's opening left or right, we have to use this formula. So now we're going to be using this. So we're going to check our vertex. Our vertex is still at 0, 0. Yes, John?
For the second equation, will the 1 still be plus 5?
This one is going to be positive because it opens up. This one's going to be positive because it's to the right. The only time it's going to be a negative is if it opens down, like on this one, or if it opens to the left. That's what causes it to be negative. Is that what you were asking about?
Yeah, I was asking for like the equation.
Yeah, the equation here should be positive. Okay. All right, so on this one then, our vertex didn't change any. And so here the p-value, though, is going to be the distance from the vertex to the directrix. How far is it from 0, 0 over to negative 7, 12? 7 12, right? So now I want to use 4p in the formula. So I'm going to have to do 4 times p. And so that's going to give us 28 twelfths. And what does that reduce to? 7 thirds. Okay, so that's the 4p value. So I know the 4p value is 7 thirds because I just multiplied the p value by 4 and I got 7 thirds. So now I have to use this equation, and it's going to be x equals 1 over my 4p y squared. This would be okay. This is the correct equation, but it really isn't in a great form because we usually don't want to have a fraction within a fraction. So think about what this means. It means 1 divided by 7 thirds. Well, that's the same thing as 1 times 3 sevenths. So instead of writing this as 1 divided by 7 thirds, it makes more sense to call it x equals 3 sevenths y squared. So when you check your answer in the back, they're not going to leave it as 1 over 7 thirds because that's what we call a complex fraction. So they change it like that. right, let's look at number 8. Again, we check the vertex. The vertex isn't anything different than usual. It's still just 0, 0. We have to identify the p-value. Gabby, what is the p-value in this one? So 3/5 is p. So now we have to figure out what is 4p. So I have to multiply that p by 4, and that's going to give us 12/5. Now, we have to figure out which of those equations we're going to use. Is this a y equals or an x equals equation? Yeah, Audrey? I'm going to get to that in just a minute. Okay, so we're going to use this equation, right? Okay, and because this opens down, we now want to use the negative form of this one. You can do it either way. Like, you can take care of the negative now, or you can do it at the end. I typically do it at the end of it. It doesn't matter. So we have y equals, and I have to make it a negative 1 over the 4p x squared. And the reason it's a negative is because it's opening down. And now you guys go ahead and simplify that. Ben, did you get it? What is it? Good job. So that's correct. Okay. I want to do one more, and it's not this one. I'm going to give you a different problem. So I want to tell you the directrix and the focus. So I'm going to tell you the equation of the directrix is going to be y equals 4. And I'm going to tell you that you have a focus at 3, -2. And we're trying to come up with the equation for that information. I think you're best if you graph at the same time that you're trying to figure it out. So I'm going to go to y equals -4. That's right here. I'm going to go to 3, -2. I'm sorry, it was y equals 4, +4. So ignore that. Our focus is at 3, -2, right here. So here's our focus, here's our directrix at y equals 4. Now, to find out the vertex, remember the vertex has to be right in between the directrix and the focus. So how far is it from 4 to -2, everybody? 6. So I'm going to have to go down 3 from here. So there is going to be my vertex. So that point is going to be 3, 1. Okay, so I know that the vertex always has to wrap around that focus, so it's going to have to open down. So I know my equation then is going to have to be y equals 1 over 4p has to go here. P is the distance in between these, from the vertex to the directrix or the vertex to the focus. That's a distance of 3. So what am I going to put under here, everybody? 12. And what do I have to make sure to also put? Negative. So I'm going to have that, and then it's going to go x minus 3 squared plus 1. That would be the equation. Do you understand what this is? What's this right here? This is my vertex. So it's the hk. It always goes x minus h squared plus k. Any questions? All right, good job. Your homework's on the board, and that's it. Guys.